Hello there. Welcome to question number 21 of the revised GRE general test. Now this question here is a question on a kind of statistical problem. Now what you're told here is you're given a graphical problem. So the best way to handle graphical problems is that you need to study the diagram first before you begin to attempt the question. So let me teach you how you're going to study graphical problems like this. So the very first area where you would like to look at is the title. Now the title is very important. When you read the title, it gives you an overview of what you're about to look for in the graph below. So what we are told here is the graph below is the energy used per meter. So the energy used per meter versus the speed during running and walking. Again, the energy used per meter versus the speed during running and walking. So the energy used per meter is going to be the y-axis, like you can see here, and you've been given the units, and then the speed during running and walking. So this is the speed here. So for running and walking, they've been given different legends. You can see here. So the legend for running is the thick mark. So you can see the thick mark here is representing running, while the one that has a lighter color is as a thin line is for walking. Okay, so let's go ahead and understand the diagram. So what we have here is, it says, you can see this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then here you have 0, 100, 200, 300. Now usually whenever I have a little disparity in the way the graph is being labeled, what I do is I strongly advise you just fix in some numbers here, so it will help you in answering the problems. So if from here to here is 100, then it implies that here is going to be 50. So if here is 100, 200, then here is going to be 150. So 200, 300, here will be 250, and here will be 350. So you can see I'm still addressing the whole situation. So it's going to make me comfortable when I want to answer the question. All right. So the next step is, now the very first step again, what I did was I checked the title to know the kind of graph I have below. The next thing is I checked to confirm what I have in my y-axis and my x-axis. I saw the legend, so I saw which one was representing the running and which was representing the walking. So the next thing I want to do is I want to try and understand the graph before I even attempt to answer the question. So what it says here is, when the speed is 2, you can see this is 2 miles per hour. So when the speed is 2 miles per hour, the energy that a person is using, that is, so now I'm dealing with this thin line. Now the thin line is for walking. So the energy being used when the person is running at a speed of 2 miles per hour, you can see it corresponds to about 140 joules per meter. Now when this person increases the speed to 3 miles per hour, the energy used is increased to about 151 joules per meter. So when the speed is increased furthermore, you can see maybe when the speed is 4, it goes to 200. So the higher the speed, then the higher the energy used per meter. So this is when the person is, you can see this line is for walking. So when the person is walking at this rate. But then if the person is running, when you're running at 2 miles per hour, the speed the energy you're using at 2 miles per hour is around 330 joules per meter. But when you're running at a speed of 3, that is the higher the speed now, there is a reduction in the number of energy you're using. So you can see it corresponds to a lower amount of energy, which is about 280. Now when the speed increases to around 5, you can see it begins to increase again. Alright, so now we know what the whole picture is saying now. So now for a clear demonstration, so let's just write, so when the speed is 2, so when the speed is 2, that is when the speed is 2 here. Now for walking, what we observed was the energy used is around 140. 140 joules per meter. But for running the energy used is around 300, and so for running, that is for running, the energy used is around 310 joules per meter. That is 300, that's 2 is around 310 joules per meter. So this is an example, a scenario of the whole picture. Now let's go back to the question. It says if S is a speed in miles per hour, so that is if S is one of the numbers we have here, if S is a speed in miles per hour at which the energy used per meter during the running is twice the energy used per meter. Now there's something there. The energy used per meter during running is twice the energy used per meter during walking. Then according to the graph above, S is between when and when. So the energy used per meter during running is twice the energy used per meter during walking. Now this is for running here. You can see running is around here, and this is for walking here. Now at this point here, the energy used here is around this corresponds to 310. Let's say this is 310, and this corresponds to 140. So at, let's say at 2.5, so 2.5 is somewhere around here, which is still close to 100 and let's say 40 or probably 45, anyone. And then here is around 2, okay, this is around 300, so this is 300. Now when you get to 3, what you have here is 150, so you have 150, and then at this point here, at that 3 here, this corresponds to 200 and let's say 60. So you could keep on going and going like that, but then what you observe is the moment you begin to, this is 150. 150 is almost twice 60. 140 is almost twice 300. This is not an accurate graph, but it gives us an overview of what's happening here. Now if we want to look at the options here, between 2.5 and 3.0, that is between 2.5 and 3.0, the gap between running and walking is like this gap here, which is almost twice. That's almost twice. Now between 3.0 and 3.5, between 3.0 and 3.5, the gap is reducing. You can see it's reducing. And if you look at 3.5 here, this corresponds to this is about 180, and for running, this corresponds to around 260, which is because twice of 180 should be 360. So this can be the answer. So if you go to 3.5 and 4.0, 3.5 and 4.0, now you'd observe the gap continues to reduce, and then suddenly the running overshadows walking, and then this relationship here can't hold anymore. So the only option that seems to make more sense in all of them is going to be A, because A is from 2.5 and 3.0. That is 2.5 and 3.0 is where you have a very good amount of comparison. That is that has this clear relationship, and that should help you in understanding how to answer questions, graphical problems of this nature when it comes to answering questions in the revised GRE general test. Thank you for watching.